Geometry. This is Unit 4, Lesson 9 on page 493 of our workbooks. It says a triangle with side lengths 3, 4, and 5 is a right triangle by the converse of the Pythagorean theorem. That means 3 squared plus 4 squared does indeed equal 5 squared. So what are the measures of the acute angles? So notice I drew a right triangle. Go ahead and draw one. I labeled the smallest side 3, the medium side 4. Notice those two sides are on my right angle. And the hypotenuse is 5. So the acute angles would be these two angles. So, and they're complementary. I know they add to 90. So let me put my theta here. I want to find theta. I want to figure out what it is. Okay, well, this would be my side opposite. The 4 would be my side adjacent. And the 5 would be the hypotenuse, the longest side, the one across from the right angle. So since I know the 3, 4, and the 5, all three sides, I can use all three trig functions. This could be a sine problem, a cosine problem, or a tangent problem. It doesn't make a difference. Which one do you want to write? I'll write sine. So I'm going to write sine of theta equals, and now I have to do opposite, which is 3, over hypotenuse, which is 5. But I could have wrote this to be tangent, sine, or cosine, but it does change what I would write on the right side. So this is one of those problems where I'm trying to find what theta is. So I'm going to take the sine inverse of both sides. You're not multiplying by it, you're taking the sine inverse. My sine inverse and sine cancel, and theta equals sine inverse of 3/5. So I have to put this into my calculator. Let me use this calculator, and I'm going to do the sine inverse of 3 divided by 5, and I find that that's 36 point, and I've got several different ways I can leave this, but I think I'm going to write 0.87. I'm going to go ahead and round that 6 up to a 7 degrees. And this is what my theta is. Let's just review how to do that on the light gray calculator, if that's what you're using. This is the same way your phone calculators will work as well. So I have to find out what's in parentheses first. 3 divided by 5, and careful, equals. That's the number inside my parentheses. And I'm going to do the sine inverse, so second and sine, and I get the exact same answer. Cool. So I know what this one is. So the other one then, so this one is 36.87 degrees. And I know this problem, I could calculate it with sine, cosine, or tangent, or I know the two angles are complementary. So I'm simply going to do 90 minus theta, which is 36.87 degrees, and 90 minus 36.87 gives me 53.13 degrees for the other angle. So this angle then is my 53.13 degrees. Awesome. So let's take a look at another problem. Let's take a look at this first problem. It says to find all the missing sides and angle measures. So this first problem right here, I'm going to use the Pythagorean theorem to find my missing side AC. If this is a right triangle, I know that a squared plus b squared has to be equal to c squared. That's my Pythagorean theorem. C squared is always my hypotenuse. So the 10 is the number across from my right angle, so the 10 is my hypotenuse. So I just have to make sure I put the 10 by itself on one side. And then 9 and AC go on the other side. I don't care which one's A, I don't care which one's B. It makes absolutely no difference. So AC squared plus 9 squared. So let's do that math. AC squared plus 81 equals 100. Let's get AC by itself. So let's subtract 81 from both sides. And I get AC squared equals 100 minus 81 would give us 19. So now I'm going to use my calculator because I'd like to take the square root of both sides. The square root cancels the square, and I get AC equals. And when I do the square root of 19, I get approximately 4.4. 4.4 units, since I'm not sure what we're measuring in. 4.4. So now I'm also supposed to find my angles. So I need to find B and C. I'm going to find one of them, and then I'll just subtract from 90 to find the other one. It doesn't matter. I know all three sides, so I could try to find B or C. Makes absolutely no difference. I'm just going to choose B. And then again, since I know all three sides, I could use sine, cosine, or tangent to do this problem. I'm going to choose to stay with the 9 and the 10, just in case my 4.4 was wrong. So when I do that, if I'm trying to find B, the 4.4 is my side opposite, the 9 is my side adjacent, the 10 is my hypotenuse. So if I'm going to use the 9 and 10, that's adjacent and hypotenuse, that's cosine. So I'm going to set up a cosine equation. The cosine of B equals adjacent over hypotenuse. I'm now going to take the cosine inverse of both sides. That means cosine will cancel, and I get cosine inverse of 9 over 10 on the right side. So now this becomes a calculator problem. I'm going to find out what 9 divided by 10 is, 0.9, and then I'm going to take the cosine inverse of that. When I do that, I get 25.8. So B equals 25.8 degrees. If you're working with the other calculator, you're simply going to type in cosine inverse. Don't forget to hit your second button, cosine inverse of your 9 divided by 10, and you get the same 25.8. Now to find C, you could set up trig calculations if you want to, but remember, C is simply 90 degrees minus whatever B is. So 90 minus 25.8 and 90 minus 25.8, you should have got 64.2 degrees. So I'd like you to try both the second and third triangles on your own, find your answers, and then come back and see if you got them correct. Welcome back. How did you do? I hope you got the correct answers. I want to mention that depending on how you set up the problem, maybe you actually solved for E and you did subtraction to find D. That's fine. Your answers would be similar to mine. I also want to mention, because I usually have a couple kids that wonder, if you had wrote this as 55.19 degrees, because that's what was on my calculator when I rounded to 0.2, then, for example, you probably wrote this as 34 point, it was 55.15 on my calculator. And so you would have had 34.85 perhaps here. That's fine. The decimals are okay. Whether you round, truncate, you don't round, it's completely up to you. So in this case, I just want you to notice that if we're differing by decimal places for whatever reason, I'm sure it's just fine, but don't hesitate to come to office hours if anything about finding these answers confuse you, or you want to talk a little bit about how to leave your answers. Let's go to the next page and look at number 3. So number 3 on this page is talking about the picture up above. Let's say we have a 13-foot long ladder. So let's go up to our ladder and write 13 feet. And we need to climb to a 12-foot tall roof. So from the ground up to my roof is 12 feet tall. So then the problem says, if you put the top of the ladder at the top of the wall, what angle is formed between the ladder and the ground? So the angle, and I'm going to move my work up here so I can quit sliding my workbook back and forth. The angle of the ladder and the ground. So this is my ladder and this is the ground. This is my angle. So this is the angle I'd like to find. So I know the 12 is my side opposite. I know the 13 is my hypotenuse because the wall and the ground make my right angle. And the distance on the ground that my ladder is away from the wall, I don't know. So obviously this problem, since I don't know the adjacent side, it's going to be an opposite hypotenuse problem, which means it's a sine problem. The sine of theta is equal to opposite 12 over hypotenuse of 13. To solve this problem, I would need to do the sine inverse of both sides to cancel this sine. And when I do that, I would have theta equals sine inverse of 12 over 13. So let's put that into my calculator. I'll use the navy one for this one. So on this calculator, I'm going to put my sine inverse in first, and then I'm going to put my 12 divided by 13 and hit equals, and that looks like it is, theta is 67.38 degrees. 67.38 degrees, or 0.4. So let's take a look at the summary for just a moment. I want to talk about vocabulary. So in this summary, they start talking about arc, tangent, arc, cosine, and arc sine. This is another term for the inverse. So for example, in this last problem, you did inverse sine of 12 over 13. So you did sine inverse or inverse sine, order doesn't matter there, of 12 over 13. That's the same thing as arc sine. That is the same thing, arc sine of 12 over 13. So sine inverse and arc sine are the same thing, just like cosine inverse is the same as arc cosine. Oh, sorry, I need to move this up a little bit. And tangent inverse that we've been doing is the same as saying arc tangent. I've not been using this terminology because it does not appear on your calculators. This does not say arc sine. This does not say arc cosine. This does not say arc tangent. So in our class, we've been using cosine inverse, tangent inverse, and sine inverse. But if you see the words arc cosine, arc tangent, arc sine, you could always just cross it out and literally write sine inverse above it. Cross it out, write cosine inverse above it. Cross it out and write sine inverse above it. This way, you won't get them confused. Thank you very much.